Hello, let's take a look at the final coursework. So much of this coursework is dedicated to building a little window manager in a structured way. So when you're done, you should be able to run it and you'll get something like this. So you see I have two windows. I can resize them, I can move them around, I can switch to the other window, I can change what's displayed in the windows, etc. So lots of fun. So that's what we're aiming for. But before we get there, we have quite a lot to do. So we have 40% of marks to be collected in this coursework. So that's quite a lot. And my recommendation, if you get stuck, would be to try to move on, because there's quite a lot of low-hanging fruit marks scattered throughout the coursework. So don't give up, but keep moving. So let's discuss this part by part. So the first part is actually nothing to do with the window manager, but as something fun from category theory. So you get used to those concepts as well. And what we're exploring is this concept of what it means for an object in a category C to be terminal. And let's explore this on the whiteboard like this. So if we have a category C, so draw that as a big blob, and then in here we have some objects. And if we now consider what it means for a specific object X to be terminal, so you have some morphisms between these objects maybe, then X is terminal if there is a unique morphism from every other object to this one. So that means there has to be exactly one. So if there are two from here, for example, then that would mean that X would not be terminal. And if there is some object here which might have morphisms to other things, but it does not have a morphism to X, then that would also mean that X would not be terminal, right? So it is the case that some categories have terminal objects and others don't. It's not something that every category has. So for the first part here, we're going to explore and see that set actually has a terminal object. So you have to come up with what that object is, and then you have to prove that your guess was correct. And similarly here for monoids, you have to find a monoid such that for every other monoid there is exactly one morphism to it. And then here instead I'm asking you to find some category which does not have a terminal object. So for every object of this category you need to show that it's not terminal. So you have to violate these conditions that we had before, right? And here finally we have the notion of what it means for two objects in a category to be basically the same, just like we had for sets earlier. That means that we have morphism from X to Y, morphism from Y to X, and if we compose them, then we get the identity. So what this means is that if I have my X here, that's the wrong color, so I have my X here, and I have my Y here, then there was one morphism from X to Y, and there was a way to go the other way. Code from, and now if I first use this morphism and compose it with this one, then that should be the same thing as just staying at X with identity, so nothing happens. Similarly, if I start here, I use from to go here, so really going below here and then I'm going back again, that should be the same thing as the identity on Y again, right? So there's ways to translate back and forth, and going there and back again does nothing. It's the same as just staying with the identity. Okay, so that's the notion of two objects being isomorphic. And what I'm asking you to prove here finally is that if you have two terminal objects, so X is terminal and Y is terminal, then they must in fact be isomorphic. So you will have to use the property of being terminal to deduce this, which is a little bit trickier. Okay, so that's the end of part one, and then we move on to actually starting to build our window manager.